The XQ-58A Valkyrie drone represents a major leap forward in how the United States and its allies can project airpower in the coming decades. Designed and developed by Kratos Defense and Security Solutions, the Valkyrie was created from the outset to deliver meaningful combat capability at a fraction of the cost of traditional crewed aircraft, while still preserving key performance attributes like stealth, autonomy, and adaptability. Its entrance into the European defense space through a new partnership with Airbus underscores both the maturity of the platform and the increasing urgency with which nations are looking to augment their airpower through advanced unmanned systems. The Valkyrie is not just a drone, it is part of a fundamental shift in air combat doctrine. For decades, dominance in the skies has relied heavily on expensive, manned fighter jets flown by highly trained pilots. While that model still plays a critical role, modern combat scenarios demand more versatile and scalable solutions. The XQ-58A was designed to fly in concert with manned aircraft, acting as a loyal wingman that can support missions without placing human pilots at risk. The drone can carry out a range of roles including surveillance, target designation, strike, communications relay, and electronic support. And critically, it can be produced and operated at much lower cost, meaning forces can field more aircraft and maintain greater operational tempo. Its stealthy design helps it survive in contested airspace, giving commanders the ability to send it forward on missions that would be too dangerous for crewed aircraft. Its small radar cross-section, combined with autonomous mission execution and precision coordination, allows it to operate deep inside threat zones while maintaining connectivity to manned platforms or ground control. One of the features that truly sets the Valkyrie apart is its runway independence. It is capable of launching from rails, including from portable systems that can be deployed in austere environments, providing a new dimension to operational flexibility. This ability to operate without traditional runways offers tactical advantages in situations where fixed infrastructure may be targeted or unavailable. The decision to bring the Valkyrie to Europe through a direct collaboration between Kratos and Airbus is strategically significant. Europe is rapidly reassessing its defense posture, especially in the face of rising regional tensions. There is a growing demand for systems that are ready now, not decades from now. The Valkyrie fits that need. Airbus will adapt the platform to integrate a new mission system developed specifically for European use. This mission system is designed to be platform agnostic, allowing it to be installed not only on the Valkyrie but potentially on other future platforms. It will provide command, control, and communications functions tailored to the operational needs of European air forces. Kratos has indicated that this version of the Valkyrie will be tuned for European missions. While the specifics of these changes remain undisclosed, it likely includes updates to the communication suites, data links, and software algorithms to match European command structures and threat scenarios. These upgrades are intended to ensure interoperability across NATO while giving European operators direct influence over the system's capabilities. The plan is to deliver operational versions by 2029, with Germany positioned as the lead nation. Germany's interest in this platform signals a shift in how European nations are approaching force modernization. The Valkyrie may serve as a critical interim capability while longer-term development efforts continue. It is a real, flying system with an established flight record and increasing integration into active U.S. military testing programs. That credibility matters, particularly for governments that want capability they can rely on, not just concepts on paper. Operational testing in the U.S. has already shown that the Valkyrie can fly in complex missions alongside crewed fighters, maintain formation, respond to dynamic instructions, and support autonomous decision-making based on real-time inputs. These tests provide invaluable data and reduce risk for future operators. With each flight, the system gains more maturity, both in terms of hardware performance and software adaptability. This makes the transition to operational use in allied nations much more straightforward and accelerates timelines for full integration. There are also strategic benefits for the U.S. in this deal. By enabling trusted allies to deploy proven American systems, the United States strengthens interoperability and alliance cohesion. The use of U.S.-developed platforms under partner nation control helps ensure shared tactics, techniques, and procedures. It also helps shape the future battlefield in a way that favors U.S. technologies, doctrine, and industrial influence, ensuring continued strategic alignment. Airbus, for its part, brings industrial scale and deep regional relationships that will help smooth the path for procurement and integration in Europe. By participating in the platform's customization, Airbus ensures that European air forces have a voice in the system's evolution while maintaining sovereignty over sensitive technologies. It also helps build a European support and logistics base that will ensure sustained operational availability once the Valkyrie enters service on the continent. Unlike many future-looking drone programs, the Valkyrie is flying now. It's collecting mission data, being pushed through advanced trials, and continuously improving through live testing. This is not a science project, it is a real tool with real impact. The drone's architecture is modular, meaning it can be reconfigured for different payloads or mission types quickly and efficiently. Whether it's flying in strike coordination, electronic support, or forward reconnaissance, it brings flexibility that few systems can match. This modular approach also supports rapid upgrades. As threats evolve and new capabilities become available, components such as sensors, mission computers, or communications links can be updated without redesigning the entire aircraft. This ensures that the Valkyrie can stay ahead of adversaries and maintain tactical relevance over a longer service life. And because of its relatively low cost, these upgrades can be scaled across a fleet without breaking defense budgets. In many ways, the XQ-58A Valkyrie signals the future of combat aviation, one where smaller, smarter, and more autonomous systems work in coordinated fashion with crewed aircraft to dominate the battlespace. It also signals a more distributed, resilient approach to force projection, where drones can be launched from closer to the fight, reducing response times and increasing mission density. The European deployment of the Valkyrie underlines a reality: the demand for capable, tested, and affordable unmanned aircraft is no longer a question of if, but when. And the answer is, right now. The US is showing leadership not only through its own development programs, but by empowering allies with the tools to enhance collective defense. The Kratos-Airbus partnership is a concrete example of this approach, and the Valkyrie is well positioned to play a defining role in the future of NATO airpower.